Mr. Schnurr is going to skydive at 6,000 meters above Cheshire. Suppose he will open his parachute at 1,000 meters, glide for 3 minutes, and face no air resistance because he teaches AP Cal. As Mr. Schnurr starts his skydive, Mr. Casella is told to pick Mr. Schnurr up. Mr. Casella is at distance of 8 meters away and starts driving straight to Mr. Schnurr's landing position at a velocity of 10 meters per second. Mr. Casella accelerates at a positive constant rate and successfully arrived at the landing position with a velocity of 40 meters per second where Mr. Schnurr just landed. Find the n in meters.
Mr. Schnurr is free-falling 5,000 meters. In this case, velocity is equals to g times time, since there's no air resistance. T equals the time and g equals the acceleration constant, which is 9.8 meters per second squared. The disposition function, also the distance function in this particular case, is equal to the integral of the velocity function. Integrate g times t equals the half gt squared plus constant c. When t equals 0, as t equals 0, since Mr. Schnurr just started the free fall, substitute 0 to the equation, and then you got the c equals 0. The st value is equals to the free fall distance or disposition, which is 5,000 meters for Mr. Schnurr. By given the st, we apply the equation to solve for the t, the time Mr. Schnurr free fall. Then 5,000 meters equals to half g times t squared. By calculating, we found out that t equals 31.94 seconds. Mr. Schnurr has free fall for 31.94 seconds, and he glides for 180 seconds. So the total time he traveled is 211.94 seconds. This is the time Mr. Schnurr traveled, but this is also the time Mr. Casella traveled, since Mr. Casella arrives at the landing position when Mr. Schnurr just landed. Mr. Casella has an initial velocity of 10 meters per second and a final velocity of 40 meters per second. His acceleration is equals to the delta v divided by the delta t. Delta v equals v final minus v initial, so 30 meters per second. Delta t equals the time Mr. Casella took to arrive at the landing position, so 211.94 seconds. This acceleration then equals to 30 over 211.94 meters per second squared. Velocity function equals to the integral of acceleration function, so integrate at equals to 30 over 211.94 t plus c, the constant. When t equals to 0, Mr. Casella have an initial velocity of 10. Apply the given t in vt value to the vt function. We found out that c equals to 10. The disposition or the distance function is equals to the integral of the velocity function. So integrate vt, we found out st equals 30 over 423.88 times t squared plus 10t plus the constant c. When t equals to 0, st equals to 0, since Mr. Casella hasn't traveled any further yet. So By applying the given t and st value into the st function, we found out that c equals to 0. So Mr. Casella's disposition or distance function equals to 30 over 423.88 times t squared plus 10t, and no need for plus 0. We know that Mr. Casella has drive for 211.94 seconds. So substitute this t into the disposition or distance function. Now st equals to 30 over 423.88 times 211.94 squared plus 2119.4. So the final result for n is equals to 5,298.5 meters.